with the most recent version. I tried to update along with the video, but
The GitLab version still has, it's still running Unity 5.6.2 F1 with the correct version of HoloLens toolkit for that version of Unity. So if you're still running Unity 5.6, then you can use the project online. If I think it was something like Wednesday is when they released the new version of the HoloLens toolkit. So if you started the project after Wednesday, it means you went and downloaded it from there, and you had the newest version then. And there was some incompatibility between the 2017 and the 5.6 versions, so you couldn't run one with the other. There was just one line in the entire application that was changed from one version to the next.
5.6 became 2017.
They've changed their versioning to now be, instead of a 5.6, 5.5, 5.6, it's now 2017.1.
Such a major difference that we actually pick up on is a major iteration.
It is. It's a. Let's see. We can take a quick look at the differences.
Is GitLab back online?
GitLab is back up. Yeah. All right. So a lot of the new stuff in the new 2017 edition of Unity is focused towards artists and designers, and it's to make it's more about like. I think they're trying to set it up to be more like a tool that you can, a designer or someone can prototype in quickly to have a story. So animations and camera trackings and stuff like that are all built into Unity instead of having to write scripts for them. From the technical side of things, this is just slightly too big.
Could you add that link to slide?
Yeah.
That would be great.
Whoops.
So if we've got the current version of each, they would be in sync again?
They would be in sync, yeah. For about 2 days there, they were out of 2 or 3 days. They were out of sync. Now they're back into sync again. If you look at the Holo toolkit now, it says that they are updated to 2017.10 F3. So
When I downloaded the new version, I wasn't prompted to select a checkbox for Windows build.
Yeah.
So that led to a long process of
Yeah.
figuring out, like, why won't the holographic emulator load? Oh, I didn't download that. So then I re-downloaded like 15 gigs of Unity.
Yeah.
Okay.
That happened to you too.
No, I ended up having to go download the new Windows Store, which is now no longer called the Windows Store. I was
I
like,
didn't do that. Well,
yeah.
a thing similar to that where
The options that are available to you for installing when you're installing Unity are the same settings that you can get through here. So if you didn't select iOS at the install, you can go here and download it separately.
And that's what I had.
and just that one.
This is in the build settings. If you go to a certain platform, it'll show you a link here for everything. Like if you wanted to add Android support, go here, download the Android stuff.
You don't have to download all of Unity.
You don't, no. You can just the ones you want here. So you only have to re-download Unity if you want to update Unity's version. All right, so back to this guy. The Unity Collaborate is out of beta now, which is it's kind of like a built-in source control for Unity, except they have some extra features like live syncing, so you can see what other people are writing or working on at the same time. It's it's not going to be free forever. It's going to start costing money in October. So it's a pretty cool feature, but it's going to be something like $10 a month or something like that to use. So
It's not that much. I mean, considering the functionality, you're going to be using it.
yeah, if you have a team that you're working with, that you guys are, working remotely, then it's not bad. But something like GitLab is still going to be free, so it's just an extra step essentially, or it saves a step. The live collaboration is kind of cool. That's not something GitLab can do, but it's got some cool features. Analytics, they did some 2D improvements like automatic sprite atlas generation. I think this is, so a sprite atlas is loading textures into memory can be expensive, especially if you have a lot of little textures. And what an atlas is, it's one texture with a bunch of images in it, and those are all referenced by their location in that texture. So then you can just load up one texture into memory and just reference a portion of it. And what this new improvement does is you can select a list of sprites, or in this case, it looks like they're doing a tile set, and that'll automatically put all of those into a sprite atlas for you. So you can, it's called packing atlas, and you can pack it into a single image. So it's a performance improvement.
You generate an index of symbols for words.
Yeah, well, Unity is going to take care of most of that for you by you load up a single sprite atlas and then you can just reference it by this sprite. Everything in Unity is going to be this sprite, even though it's referencing just a single location in a large texture of pictures. Some sprite masks as well for 2Ds. The playables, which are like data sources. It's like it's a visual graphing interface, so that you can create mixing and blending from multiple data sources for different effects and things like that. It's Unreal uses a tool kind of like this for their kind of visual scripting, and Unity is kind of getting into that now.
How hard is it to learn Unreal now that we have this much of a foundation in Unity?
It's going to be.
It's different.
Yeah, it's going to be like relearning maybe 75, 80% of the stuff. But you're going to know the things to look for, right? You're going to know the things that you can do, and you're going to say, then you're going to be able to say, okay, how can I do this thing over here? It's going to be a lot easier to relate to that instead of, I have no idea the things I can do, so I don't even know what to look for, right? So they have some new editor stuff. There's the profiler for the UI. Profiling is basically a way to take your code and run it through a profiler, so you can see what parts of the code take a long time to run. And this is useful if you have lag in your game, like your character's running along and then this stuttering. You can figure out kind of what code was running at that little piece to try and optimize it. Maybe put it into a coroutine. If you're loading a bunch of assets, you can load them over time instead of trying to load them all in one frame, or various situations like that. It's just gives you this graph right here. Kind of gives you a good example of this is frames per second, and so it'll give you frames per second and then milliseconds per frame. So it'll show you how long each of your frames is, and if you have very long frames, then that's going to be a low frame rate, which means low performance, stuttering, stuff like that. Asset bundles. They have, this is pretty cool. The C#6 is the latest version, or almost the latest version of C#. just like Unity and HoloLens Toolkit and everything, languages like C#, C++, they're all improving over time. They're not quite as fast as other things, but they add new features, new functionality um, uh, to the language itself, to the base language, so you can do new things with it. Okay. C#6 has some pretty neat stuff as far as making things like checking for nulls easier and kind of options like that. There's a lot of features that aren't in the current version in .NET 3.5, which is what Unity uses now compared to .NET 4.6. So. Model importer, some lighting stuff, real-time shadows, improvements. Lots of new features in the 2017, and some of the stuff that was in the previous version has been deprecated, which means it's no longer supported, and that's why the new version of HoloLens Toolkit or Holo Toolkit was necessary, is because it was using functionality that was kind of suddenly deprecated, and it wouldn't work anymore because it was trying to access a method that was now changed. The signature was changed, so instead of taking one argument, it was supposed to take two. And so when it tried to compile the Holo Toolkit, Unity thought that that was a incorrect method, but it was really only incorrect for that version of Unity. So these are kind of things that you'll run into. This is like the standard day-to-day thing, is overcoming little challenges like these in software development. So, lots of new features. Take a look at these, watch some of the videos, see what kind of stuff has been added. So last class, congratulations on making it this far. I was looking up some of the statistics. The attrition rate for engineering students is about 60%, which means 60% of people who go into an engineering type field leave the field before they're done getting their education. And that's fairly high. It's because engineering is not an easy field. It's challenging concepts that are you almost have to be born that way. You have to have the engineering mind. It's a hard thing to train. Some people can do that, but for others it's too difficult. Okay. So nice work. Keep it up. There is a reason that that engineering jobs pay so well, and that's because engineering is hard. Okay. And if you haven't looked up like Glassdoor salaries and stuff for engineering, you should do that, at least for a little more motivation into why you'd want a job in engineering. They pay fairly well. So what we're going to do today is just kind of do an entire class review. I didn't want to start anything brand new because we weren't going to really have a chance to try it out and test it. But we're going to go through all the stuff that we learned about Unity, give you guys an opportunity to ask questions about anything along the way, and then if we have more time, then I'll go into some like best practices and other tips and tricks and stuff like that to help you progress with your studies in Unity. Okay. So, is there any questions to get started with about the entire anything in the class that we've learned so far?
I feel like I'm still struggling with the vocabulary.
Okay.
The methods and functions and objects and types and punctuation.
Okay. Yep.
You can go over debugging a little bit more.
Yeah.
Best practices for that. I feel like going forward, that's probably what I need.
Okay.
Debugging.
Debugging, yeah.
And maybe even tools that you, or I don't know, these tricks that you've learned. I mean, I saw that you would like print SMS to the console to identify where, but
Yep.
maybe you could just go over like there's those little icons at the top that are breakpoint.
Yeah, the breakpoints are going to be, I find them to be much more powerful than just putting in a debug statement. And I'll show you why. We can kind of do both. Yeah, we can do both at the same time. We can step through the terminology as we're stepping through the code in the debugger. Okay. Yep.
Sort of along with best practices, I was wondering if you have like other like tutorial areas to go to, like beginners. So
Yep. Yeah. Next steps.
Yeah.
I have a list of some next steps we can go over as well. So. Okay. So let's pick a script to step through. We'll do something. We'll try the my controller script from the VR room editor because that's complex enough to give us some variety, and it's something that's complex enough that we want to step into it and debug. Yep, recording.
Mind wanders. I like
Okay. So get into position. Okay. Need to adjust my Daystar protection. Guess I could work on my tan at the same time. This is the previous version, yeah.
so if you tried to open it through 2017, like it's possible that
I believe that this guy would work through the newest version. There's no incompatibilities that prevent it from working for Steam VR. I haven't tried it yet, but I'm pretty sure that's true.
I tried it earlier.
Okay. The Holo Toolkit, so the Unity typically does a pretty good job of saying, you know, in updates before they deprecate something, they mark it as deprecated. So you get a warning in your code that says, this is deprecated, you shouldn't use this anymore. And then a couple updates later, they'll remove it entirely. That did not happen in this case because the code that they deprecated was part of the Unity editor interface so creating custom inspectors and stuff like that. The Holo Toolkit had a custom inspector for modifying, I think it was a texture or something like that. Unity doesn't have the same, I guess, the same protocol for deprecating their internal stuff for the Unity editor. They'll do it for everything that's the public stuff, but so if you had a game or something, an app that you were releasing, anything in there would be, it would take a while to be deprecated. But since the Unity editor is just for the developers, I guess they're not as worried about it being suddenly deprecated. So, all right, so we have our scene going. There's our pointer. and we're looking at the myController script. myController is a class that extends the monoBehavior class, and a class is a blueprint for an object. Okay, this is used to create an object in the game world or in the scene, and that object is being created right here on controller right. So when this script is attached to the controller and the scene starts up, it says, this is the class I have. I'm going to use that to create an object and attach it to this controller.
But that's just for this particular class, the way it's been set up, right? Not necessarily all classes create an object?
All classes, well, there are some special case classes that aren't going to be used to create an object. Those are like static classes. Those would be things that you just call methods on to retrieve information back, process things. If you want something that's going to have data in it and it's going to be distinct from other instances of itself, then it's going to create an object and you're going to instantiate. Anything that any class that creates an object is going to use the new keyword somewhere. It's going to say, let's see if we have an example of that in this script here. This ray is a class, and right here we're creating a new ray object and assigning it to a new ray, and then the ray has what's called a constructor. And if we look at this, we say this constructor, well, so technically ray is a struct. Don't worry about that right now. Maybe it's a bad example. Structs are for things that just are data, essentially. There's typically not like large functions inside of a struct. There's some other subtle differences, but we'll just pretend it's a class, because you could change this to class and it would work almost identically. Okay. It has a constructor, and a constructor is just the same name as the class. So you see there's no return type here because it's returning itself, basically. This is saying, if you want to create an instance of me, these are the values that you need to give me. Okay? It needs an origin and a direction. That's all you need to create an array, because it needs somewhere to start and somewhere to point. Okay? Because it's an infinite line starting from some point in the world.
And can you set the length of array so that it's not infinite?
If you set the length of array, then it's just a line, not array. So you can kind of set the array in the ReCap, the length, by saying, I don't want to know about anything past 100 units.
Okay.
But it's still, the array is still defined as a point pointing in a direction. There's no end point. Okay, so the array is a class. It's creating a new object of array. It's using this class right here. We can't see into the code here, but it's probably got some local variables of origin and direction. It allows you to do things like getting points, returns a point at a distance along the array. So this one you can say, you can point a ray in some place and say, what's the position 10 meters out from that ray? And it'll give you, this will return a distance, or a point in space, just by providing a distance. So it would be easy to create a line like this, is say, make a ray, say, give me a point that's 10 meters out, and now you have a starting point and an end point 10 meters out. So it's a class. We'll just assume it's a class, even though it's a struct. It's a class that has a constructor, and some classes won't have constructors, like our controller script, myController. There's no constructor in here, right? And that's because Unity handles this stuff kind of under the hood. But we've created a new object called Ray by calling this constructor on its class, which returns a new instance of this object. And now this ray object is going to be distinct from any other ray object that's created, okay? And that's because we don't want a static ray, because you might have multiple rays that you're handling and you want to pass a ray around and you want its data to keep to itself, okay? You don't want it to be generic, public or generic to all rays out there. You don't want just one ray to work with. So you need to create an object ray and you pass around that object, okay? Same thing with this raycast hit. We're defining, this is a local variable. Actually, it says right there, local variable, raycast hit. This is a bucket for an object. That's what variables are, just like this guy. We're saying, create me a new space in memory to hold an object of type ray. And so it'll go out and it'll say, okay, to create a space in memory for ray, we can't see the things attached to this, but assume it's 2 vector 3s in origin and direction. It says, okay, I need to create enough space in memory to hold 2 vector 3s, which is 3 floats each. So that's, a float is 4 bytes, so 4 times 6 bytes of memory has been allocated for this ray. And it has a pointer to it in memory, so this is kind of getting low down here. We're getting actual down to the physical hardware is saying, create this location in memory to hold this object. And here's a reference, and this is my pointer to it. So really all this is just a pointer to a location in memory, okay? That's going to hold those 2 values, the 2 vector 3s. And then we can reference that position in memory and use this class to kind of know what those things in memory are, that they're 2 vector 3s. Okay? Yep.
So where you have device.transform.position and device.transform.forward, that's the origin and the direction?
That's correct.
And so transform, or like the device transform, that is the same, like from where the object is in space. Like,
The device, the transform, device transform holds the position, rotation, and scale. So we're saying take the device, this is just another object, which is representing this physical object. It's saying take the transform of that device and get its position. That's the origin. Okay? So the origin point is there. And the direction of this ray is the transform of this object and the forward position. So it's the direction is this way, origin's here. So if we created a new ray right here, it's going to be pointing up like that, okay? Which is kind of what we see when we create that. When we create this ray right here, okay? It's going off into infinity, presumably. Its origin is right there. It doesn't go beyond that. That ray right there is visually describing exactly what the ray we're creating is this point right here that goes off into infinity in that direction. It's always facing in the forward direction of this object.
But it's
Okay?
only registering everything under unit, right? After 100, it won't take
Just this raycast is only registering those. We could make a new raycast that didn't have a distance. And that would go to infinity. Okay, that would anything that you had. I mean, there's going to be, you can only represent such a large distance inside of Unity. So after that, you get into some crazy. If you want to look it up, the floating point errors. Minecraft had this kind of famous thing. It was called because the Minecraft world is infinite, right? You can go on forever. If you're not familiar with Minecraft, it's like a block building game that you can run around in and place blocks and destroy blocks. And it's procedurally generated, so any direction you go, it generates new terrain off into infinity. But it's not actually infinity. It's you get to a point where the values representing the location of the world, floating point can only represent positions to a certain degree of accuracy. The larger the float gets, the less accurate it is. So if you went in, I think they called it the Outlands or something like that in Minecraft. If you went far enough out into the Minecraft world,
And of course, someone went that far.
someone went that far, of course. It
Which
takes,
is far.
yeah, if you went there manually, I think it would take like 30 days of walking.
Oh
Or
my god.
like literally 30 days of in-game walking. I think they just teleported there or whatever.
They
But
just left the weight on the keyboard.
yeah.
Great.
So if you went out all the way out there, the procedural generation algorithm would kind of start to break down because those positions were inaccurate. So you get this like wonky terrains and like cubes that were floating in midair and all this crazy stuff because things would just start to break down. So it was kind of interesting, but so there's no, you can't represent infinity in a game or in a 3D world just because we don't have, there's no data structure to represent infinity. Right? But you can get pretty far out there. Yep.
The raycast hit, why is that not instantiated with a new right there? Is there a new somewhere else?
Right. So why aren't we doing like a physics pH equals new physics and then doing a pH.raycast? Something like that?
Specifically the one above it, raycast hit.
Oh, this guy?
This is all by itself. Is that
Yeah, it's we're setting a location. We're saying create a location in memory to store this, and then we're using it right here. This is using this is a static method right here. So this is, we don't have to instantiate an object. This is if we look at this, navigating. This is going to be a static method that we don't have to create a new physics object to use. And I'll show you. And I'll talk about the out hit in just a little bit.
the hit is not been instantiated yet?
I'm going to talk about that in just a second. So we have this static raycast method returns a boolean that's is it hit or not. It takes array which we created, we instantiated that, and it also takes out a raycast hit info. And what this out parameter does is it tells the method that I'm going to pass you a placeholder for an object, and before you return, you need to fill in that object. You need to instantiate that object. And it's useful for situations like this where we want to return not only a boolean telling us if we hit something or not, but we also want to return information about what we hit. And since you can't have multiple return types for a method, this is a way to get more information out of a method. Okay? Let's write a quick method that looks like this. So we can say my hit, we'll take a boolean, we'll make this real simple, and we'll say out transform hit objects. Okay. Now, even if we said, if we just tried to return is hit, so we'll just return what's passed in, it's going to complain. It says the out parameter must be assigned before control leaves the current method. Before you return, you need to assign this out parameter. Okay, and so we'd have to do something like this: out. Oops, not out. Hit object equals this transform. Okay, and then when we call this method, we can say. We'll create a new transform to hold the return value that we're passing in. Okay, we're not going to instantiate it yet because it's going to be instantiated in here. Okay, and then we would say something like if my hit true out my hit objects. Oops. Okay, and so now we know that if this returns true, which we know it's going to return true because we're just returning what we pass in, but you'd obviously have something a little more complicated than just true here. If this returns true, then we know that this hit object is going to well, we'll say this. If is hit, set it to this, and else. Okay. So what this is doing is saying, if this Boolean is true, I want you to set the hit object to this transform. Otherwise, set it to null. And what that allows us to do is, if we can pass in this this conditional here, we can say my hit equals true, or my hit with a true and an out my hit object. And then we know that if we're inside this conditional right here, we know that my hit object has been assigned to. Okay, it's been assigned to this transform. It's just a way to get more information out of a method without having to create multiple methods or some kind of custom objects, something like that. Is that clicking at all? Making sense?
Where's the data that it's passing through?
Where's what?
The information that it's passing through, or you know,
Well, so for the physics raycast, we're passing an array, and we're assigning this out to our raycast hit. Okay. And this is just extra information. We don't need to worry about it for this example. We're passing an array, and we're saying if you hit something, assign information about that hit to this object, which is just a raycast hit, which tells us the point at which it hit, the normal. The normal is the vector facing off of the face. So a flat surface like this, the normal is always pointing up. It's pointing out, pointing out. Yeah, it's always perpendicular to the surface. Okay. This is just all information about the object that was hit, how it was hit, where it was hit. And this, so this raycast is saying, if you hit something, assign this hit object to the information about what you hit. Okay. And the reason it's in two parts like that, instead of just being something like, you could do this, like, let's do this. Right, if you didn't have the out parameter, you'd have to do something like this. Hit equals this, and raycast would return a hit, would return raycast hit information, okay? And then you'd have to say, like, if hit does not equal null, or whatever hit raycast or raycast hit is going to be set to. We don't know what it's going to be set. If we hit nothing, there's no information about what it hit. Okay. It would be something like this, where you have to say, ignore the red lines because this doesn't actually work. But it's just a way to get more information out of a method without having to create either, like, you could say is hit right here, like is raycast hit. If you're, I'm just making up methods right now for how we get around this, and then you'd have to do another method that said equals physics dot raycast.
so rather than returning something, you're calling the method inside that executes. And
Well, we are returning something. We're returning a Boolean saying if we hit something or not. And in this case, if we hit something, we're going to stuff that information about what we hit into that parameter that's being passed in. It's basically saying, here's a bucket. I want you to fill it if you hit something, okay? And if so, then we can say, okay, you returned a true there, so I know you filled that bucket with something useful. If it returns a false, then you say, okay, I know that that bucket doesn't have anything useful in it because it hasn't been set because you didn't hit anything.
And the out is the contents of the bucket, right?
The out is the reference to the bucket.
Okay.
so you have to have a method someplace that modifies some data outside of the function rather than returning it.
Well, that's what this out is basically a way to pass in. It passes in the pointer to that bucket. Okay.
I'm sorry, out is
Out is a keyword in C#, just like if or return or something like that. It's a keyword. Okay.
it's being used as a data type.
It's not used as a data type. This is a special. This is saying this the next parameter that I pass in is an out parameter. It's you have to use the out keyword when the method calls for an out. Okay, because what we're passing in here is an out for a raycast hit info. This is what the method signature looks like here.
Just like if it's asking for a float, it should be float.
If we were returning a float information, then it would be out float distance or something like that, whatever float would represent. The out keyword is something you can prepend to a regular
Just like new
type.
or
It's a keyword like that, just like new, yeah. Except in this case, it's used in the parameters of a method to say, this is a pointer to a location, to an object or to a variable that I want you to assign to.
what are the parameters of
You could also do a ref, which passes in a reference, which means that that object, it's red because it's not actually ref here, but ref would remove the requirement for that object being assigned to. So if we use the ref here instead, then we could just return okay. It takes the requirement for assignment and moves it out. So right now it's saying this is unassigned. So here it would say okay. It changes the location of the assignment. For the out, you're passing in something that's that you want to be assigned to, and with the ref, you're passing in something that is already assigned, and you want to either modify it or you want to set it to something else.
basically just talking about something that's already defined.
Yeah, ref stands for reference. Yeah, and the out is a similar. It's kind of a more strict version of that, where it requires you to assign something to that out before you return from your method. Okay. We're getting a little bit off into the weeds because this is supposed to be a review and we didn't cover these. But let's get back to, yeah, there's so many rabbit holes in development, and I'm very prone to go down them. So let's try and get back on track. So we have this class and this object. It's creating this object here. Okay. The example we're looking at is this ray object being created. Okay. And this is the constructor for it, which takes two arguments. And then inside there, it's probably got like I don't think I can edit this now. It's probably got like a private vector3 origin, private vector3 direction that it's assigning to itself there. So this is called what is it called? Parameter injection, I think it is. Let me look it up real quick. This is like one of the software engineering terms for it. Parameter injection. Dependency injection. Yes, that's it. Dependency injection, which is it's basically you give a class everything it needs to create itself, right? Without it having to. Because here it wouldn't know what origin or direction to use, so you have to provide that information. Okay. Okay, so we've created a new object, this ray, and then we're using that ray for this physics raycast. And again, raycast is a static method on this physics class. Okay, Most of the methods, maybe all of the methods on this physics class are static. See, static, static, static. And that just means that we don't have to do this where we say physics equals new physics, and then using this where we have a raycast here. Okay? The reason we don't need to do that because Unity is going to create this physics system that's going to tie into the built-in Unity stuff, and trying to create this new object every time would just really kind of mess things up. There needs to be one instance of physics, and they can do that with a static class. Okay. So this is the class example where you would never create an object of it yourself. Just going to be a class with methods on it. Okay. There's not even data to access in there. You can't. There's no objects data in there. It's all static data. Okay. All right, so let's take a look at debugging with this. Get rid of this code. All right, so say we're having trouble with the controller not activating a UI element, right? So we want to know if the raycast is actually hitting the UI element. We're going to set a breakpoint inside of this raycast check, okay? So if this breakpoint is hit, that means that we've successfully gone through and we've done this physics raycast against the UI layer, and we hit something, and now we're in the process of checking to see if it's a button and what it may be. Okay. So we set our breakpoint. This would be kind of like the same as saying debug log. I'm inside the raycast type thing, right? And then you just check your log to see when this triggered. But you have more options here, okay? Here you just have a message, and we'll leave it in just to see it in Unity as well. So our scene is already running. Let's find this guy over here. Okay. So without we can see that we're now triggering that. As soon as we hover over something that's a UI element, here we'll clear this, right? We start getting that method or that debug log call, okay?
And that's once each frame, right?
Once each frame, that's why you'll see it, we're already up to 100, 200, 300, a lot of messages there, okay?
So, not to distract from the debug question, but
Rabbit hole, yeah.
that it's within the update.
It's inside the update method here, yeah. But if we attach our debugger, so now the debugger is attached to Unity. It's kind of difficult. There. So now we can't switch back to Unity to look, but it sent along this debug log message, and now we've paused execution of the code, okay? So instead of the update method's not running right now, it's frozen right here on this line. And the cool thing about this is that we can now hover over objects in the debug into the editor here, and say we can get information about them. So for example, we can look at this hit collider, and we see that it's a button. Here's its size. Here's its center. We can see information about the collider. Is it a trigger? Is it enabled? What are the bounds? All these kinds of things from inside the debugger. Okay, all this information is available to us, whereas before we just knew that we were getting here. We knew we were hitting, but we didn't know what we were hitting or where it was being hit at. Here we can look at the hit information. Okay, we can see the exact point in the world that we hit something. We can see the object that we hit, the name of it, the collider. All of this information is available to us. Okay.
And how did you bring up that debugger?
So I set a breakpoint, and then there's a option to attach to Unity.
And then that just spawned it on the bottom?
Let me show you real quick again. Okay. Attach the debugger, or sorry, set your breakpoint. Okay, and then attach to Unity, and I guess we're still pointed at it. I don't know how, but
Because it's frozen.
yeah, probably. So, well, I mean, I don't want it to do that. So it's okay. Okay, so now it's attached to Unity, but it hasn't hit that breakpoint yet. So the code, right now the code is running. It's creating this ray. It's casting the ray out with the physics raycast, and it's skipping over this entire block right here. Right now it's doing this dozens of times per second, but it's not. It's skipping over because it's not hitting anything with the raycast. So our breakpoint is not being met. Okay?
So because the bool is now false.
This is returning false right now because we're not hitting anything with that raycast. Okay. So right now we're attached to it. The code is running, but our breakpoint isn't being hit yet. If we set our breakpoint right, we can add a new breakpoint even after it's attached. So setting a new breakpoint on this line, the next frame it's gonna trigger like this. Okay. So now we see that we are attached to it. It's hitting, and we can see that we're casting this ray out. We're at origin of 0.9, 0.9, 0.9, amazingly. I was holding the controller at just that spot. The direction is facing out into 0.1, 0.4, and 0.9. Okay. The hit information is going to be null. There's not going to be anything in here yet because this is an out parameter. So it hasn't, after this method runs, we can check it and see what it returns. So now we can, these buttons up here, the show next statement is going to step to the next statement. This guy is going to step into a method. So if we step into, I don't think we can step into our raycast, but we can try. Basically, when you have a raycast like this, you can either, any kind of method call, you can step into that method and then see the execution inside that method, or you can just step over it. It's kind of the layers, right? Right now we're at this my controller layer, and we can either step into the raycast layer, or we can just step to the next step inside the controller layer. And step over is the same type of thing where we step over this to the next one. And step out means that whatever method we're currently in, we're just going to cycle through until we get up to the next layer. Okay, so let's try. We don't have debug information for physics raycast, so this is probably not going to work, but we can try it. Step into. Yeah, so we ended up just stepping over it because it doesn't have the information for stepping into the raycast. Just like we can't see the code inside a raycast, we can't step through the code. So we can create our own method and take a look at that. Okay, so and you can actually just step through the code and see how the whole thing executes, right? So let's set one at the very beginning, and we can step through the code and see this ray right now is just zeros, but when we step over it, now you see that the ray has been assigned to because we created that new ray from this transform position and this forward. Okay. Step over that, and we see that now we're at this physics raycast, and when we step over, it's going to step back down to the next thing after this if statement, which means this if statement resulted in false. Okay. And then the next thing was this if pad touched, which the pad is currently not being touched. So we got into this else statement down here. So we're setting that marker active to false. Okay. And it's the same thing. You can just keep stepping through it. And that's the way the code is running right now. you know, 60 times per second or so right now. It's just stepping through these lines over and over and over, okay? But if we want to see it step into this if statement right here, then we need to point at that. So now this raycast was true. So this, it stepped inside this scope right here. And now the button, and so the raycast was true, and so now we can start getting information about what we hit, okay? So our hit is that object that we set. It has information about the collider. And on that collider, we're going to call getComponent, which is for a button. And that's going to return the button. And if that's not null, which means that it was a button, and in this case we can see that it's actually a button. There's a, this has been assigned to. So then we step into that if statement, and we call that select statement, which is, which selects the button so that it highlights. Okay. And that's what this select does like that. Debugging make a little more sense? You can see why it's powerful because you can get a lot of you can just access the entire state of your application at the time. We can see what the ray is. For example, if you're casting rays and they're not hitting anything, you can go in here and say, oh, well, that's, you know, you can maybe you could draw, you could take this ray information and draw a ray in your scene and see that's not even the right ray. Why is that being set that way? And you can go up and look and see, make sure maybe you had the some other transfer, like if you just had the transform forward, that would just be the forward vector always. It wouldn't be related to the object that you're using to point around. So it just gives you a lot more information about your scene and allows you to you take a snapshot of everything that's running, look at all the information. Helps you debug, which is exactly why it's called debugging. Because then you can find out everything you need to know about why it's not working. Okay? This is very important for those the two types of errors. There's the syntax errors and there's the logical errors. This is going to help with the logical errors because it's telling you all the information that you need to know to evaluate these statements yourself. So you can see if your logic is correct. Okay. So let's look at a debug example where we're going to step into one of our own methods. We can do that kind of like this. Okay, still running. All right, so I've pulled out, well, I probably have to restart this since I changed the code. Okay, so I pulled out the code that runs inside the trigger method to be inside of its own method, my trigger method. So if we pull the trigger, we can see that now this method's been activated. And we can step over this guy. And now we see that if we step over again, we just step over and nothing happens. We just continue to get back to this. Oops, I don't want to go there yet. My control. But if we pull the trigger and we step over and then we use this step into, this will now step us into my trigger method. Okay? So instead of just stepping over, we're going to step into this code, and then we can step through this guy and see what happens. That was a little fast, sorry. Step over, step in. Okay. So the same thing here, it's creating an array, it's checking array cast hit. If it doesn't hit anything, then we're done. But a little more interesting is if we're pointing at something. Now we can step over and step into, and the ray that we're casting is going to be pointed at something. We're going to hit it. So now we're stepping in, we can see that this is a button. And if the button's not null, then we're going to invoke its onClick method, which we assigned the onClick method to show all those other buttons. Right?
So when you step over, it's taking you to the next valid point? Like,
That's right. The next point to be evaluated.
okay. And it'll just skip anything that it's
It'll skip stuff like this guy,
right.
because there's nothing going on there but creating an empty variable. So that's why when we're stepping over, we're here, and then it stepped over to this, skipped this guy because there's nothing going on there.
That boolean was false, it just skipped that whole chunk.
Yep. Then it stepped to here, and this resulted in false, so it skipped all the way to the bottom. If we minimize that, it skipped all the way down to this guy. That was false, so it skipped to here.
Thank you.
Yep. All right, so it's invoking, and we can see that it now created these other buttons, right? And lots of raycast triggers in there. Over 1,000 now, so. All right, debugging make a little more sense? Okay. Just attaching the debugger and just stepping, like anywhere you'd say, oh, I should put a debug log there and see what's going on. Instead, just hit the breakpoint button, which is this column along the left here to set breakpoints. Set the breakpoint and attach to Unity, and you can see better what's going on. Because you'll, instead of just a debug log saying, I reached this point in the code, you can say, well, the trigger, the breakpoint hit, so I know it reached that point, and now I can look at all the data that's in there now too. And just kind of triggering, setting a breakpoint at the start of a method and just stepping through it, it really gives you a better idea of just how the code is executing and what's happening, especially like in that update method when we attach to the top and we just step through to see how it was evaluating all the code, right? It's a nice way to learn just how it steps through the code and how the flow of the code works. Okay. Any other questions about that?
Is there a comparable thing in
MonoDevelop also, you can attach the debugger. It has a debugger as well. Yeah. I personally don't like MonoDevelop very much, so I don't use it. It's been a while since I used it anyways.
I've seen a lot of like the tutorial and watching possibilities like MonoDevelop,
MonoDevelop, when about a year, 2 years ago, MonoDevelop was the primary thing people used with Unity. It's because it's shipped with Unity. If you install Unity, MonoDevelop was the editor that it shipped with. And then Microsoft got on board and created their Unity extensions or Unity plugin for Visual Studio. And then eventually, 6 months ago or maybe a little more, they started providing the ability to install Visual Studio along with Unity. And now it's certainly gaining. Yeah, I mean, Visual Studio is the standard developer toolkit, the IDE for developers that develop for Windows. You'll see some of the hardcore guys will they'll use whatever tool is most difficult to use, just to be hardcore. But Visual Studio has a lot of nice features, and it's very powerful. So, and you can also use it for other stuff too. I mean, you can create a new application in Visual Studio that has nothing to do with Unity, like let's see, a new project. You can create just a standard UI, like a Windows Forms application, which just uses, let's see here, Windows Forms. You know, this type of thing where you have buttons and stuff once this loads. You know, this could be like a utility for doing whatever. You double click on a button and that's the method for that button. And this is all separate from Unity, right? So this is something that when you hit play, it launches an application. Launch, oh, it's over here. Now you have this application that's just running on your machine, right? This is an executable, yeah. This is a Windows exe file that you just, I mean, you saw how quickly I created it, and so you could do stuff like, one of the first programming projects I did was I created it wasn't this nice, but it was using Visual Basic something old, but it went through the photos I had on my computer and analyzed the EXIF data, which is all information that the camera attaches to the picture. Yeah, dates, focal length, and aperture setting, everything about the camera. And just went through and looked at the dates of the time it took the photo, and it organized all my photos into directories by month or something. So, you know, just quick applications like that you can do in Visual Studio. So, very powerful tool.
What's the relationship between .NET and C#? Like, I don't know what .NET is. I see it around all the time.
Right. You can assume that they are basically always going to be together, .NET, C#. You can use C# in other instances that are not .NET, but .NET is going to be kind of the common framework for, you have C++ .NET stuff, they have C# .NET, F#, I think, has .NET stuff. So
Is it like a library? Or?
it's kind of like a library. It's the common library or framework between multiple languages. It's just a place that has common methods and functionality, and you would just need to install the .NET runtime one time, and you can run multiple other applications on your machine. So. Yeah, so Visual Studio, great. You can do more than just Unity with it, and it's very easy to use. I mean, you saw I created an executable with some buttons on it in a minute. So didn't do anything, but beside the point. Okay. Terminology questions, other ones? Classes, objects, methods and functions are really the same thing. Always on the other window. Methods and functions are just going to be some kind of, it's an optional but defaults to private scope modifier, a return type, the method name, which can be whatever you like as long as it doesn't start with numbers and then parentheses with optional parameters, which are just a type and with a name. Right, that's all a method is, and then you have access to the parameters that you pass in. You have access to, so you can say, you can access my string and print it out, or whatever it may be. For example, if you had this guy that, let's create something real quick. Just back to methods and the ref type, the ref keyword. So if we had this this method to modify a string, for example, we'll take like a substring is a method on string that just takes a chunk out of the string. So we can say the start index is 0, and we say this is the string is an array of characters, right? So we say I want a substring, a subset of this array that starts at 0 and goes to my string dot length divided by 2. So this is basically takes any string and cuts it in half. Okay.
And what is the 0 represent again?
The 0 is the start index. Yep. This is start index and length. Okay. Oops. Okay, so this is taking my string and cutting it in half. We'll say after. Okay, or actually let's do this. We'll pass in a variable. All right, so you can see that the before was hello world and the after is just hello. It's cut in half, so there's probably a space at the end of this. Maybe. But if we did this, we put these debug logs out here. I'm getting back to the ref statement here eventually. Right? So what's the before and after going to be here? We're taking hello, which is equal to hello world, printing it out to say hello world. Then we're going to pass it into this mod string method right here, which is setting my string equal to half the string. And then we're printing it out again.
The world won't be there after that. After the text out.
It's going to be the same result as before. Hello world and then just hello. Mm-hmm. Let's see.
Because
Hello world. Both times.
Because it's happening before that method is even called.
No, it's happening after. After is being called after the method is called. But it's hello world both times. Right? But if we pass this in as a reference, now when we run it, hello world and hello. Okay? And that's because when you don't pass in by reference, it passes in by value. So it's basically, this is creating a new string called myString, and it's assigning the contents of hello to that string. It's modifying myString, but then it just exits, and myString is gone. The modifications we made to it is gone. But hello is, it doesn't have to return anything. Okay, does that make sense? We're passing it, instead of passing it just as an object saying, here's a thing to modify, we're saying modify this thing. Okay?
But it doesn't specify what it's supposed to do with it after it's modified.
Well, it does. It says throw it away because there's nothing else going on after. This is creating a new string called myString and assigning its contents to be the same as hello. It modifies that.
Okay. So once you exit those brackets, right?
Yep.
You exit the scope of that
Mod string.
and then it's just thrown away. So that's why we have to have a way to basically get that information.
Yeah. Another option would be to say to return it, right? String. And then we assign hello equal to that. Okay. Okay, so you can either this is passing in a copy of hello, modifying it, and then assigning that modified copy back to hello.
And thus, when it goes to the next line, it's already modified.
And then so now when we get to here, it's modified. But if you're just doing that, you can even have this where it returns something, but you don't assign it. It's not going to get assigned. It's going to be hello world both times. Okay. So these are things you have to watch out for is even though you're passing in that method, passing in that value, it's passing by value, not by reference.
So why do you put the ref in the parentheses and not within the curly brackets when you're doing the ref string, myString?
Why do I put it up? Whoops, up here.
Yeah.
Uh,
Instead of on the line below where it's actually doing the work.
Because it's a keyword that modifies the input parameters of a method. It's used for saying, I'm not just passing in a value to assign to my string. I'm passing in a reference that is a string. You can refer to it as my string.
And by saying reference, you're saying hang on to this information, don't just throw it away.
That's right.
It's going to be returned to that.
You're saying instead of creating a new string and assigning its value to hello, I want you to instead create a pointer that points to hello. And so anything you do is going to be modifying this up here instead of your own local variable. Okay. So that's kind of a good way to think about methods and that reference parameters, that passing in things like this by value is not going to have them modified later. So this would be a fairly difficult bug to track down if you didn't know about this property of C#, is that things are passed around by value most of the time. There are more complex objects that are going to be passed around by reference. If you had like a list of strings and you passed in that list, adding something to that list inside this method would add it to the other object. It doesn't just create copies of those objects. Okay? Simple ones like this, these like string, float, int, the primitives, they're passed by value.
Can I ask an unrelated question?
Of course.
So a lot of times methods are listed as void.
The return type?
Return type, yeah. Because like we looked at string in class periodically.
You can return any type. You can return a transform. You can return a my controller object. You can return anything. It's just a type field. Anything that you can create a variable for, you can return as a type. It's just a type description, so it's whatever you want. So we had this object color pair is a type that we created, right? We could create a method that says object color pair is the return type. It says make color pair. And it accepts a game object and, whoops, not and, game object and a color, okay? And it returned a new one of these with color C. Oops. This is an error because we
Right.
need a constructor. The parameter names don't need to be the same there. I'm just being lazy. Okay. So now this method returns a object color pair. So it can return whatever type you want. Just depends on the situation. Maybe you want to return a transform, or maybe you want to return a new ray. Maybe you want to return, whatever it is. Could return. Could return a float, an int, anything.
Which is what you want to get back at the end of the completion of that method.
That's right.
It's so basic. I don't understand why I struggle with it so much.
Yeah, it's a way of saying, I'm going to call this method. It's going to take in these. These are the inputs. This is the output. Okay. It is fairly simple, but it's also very broad. You can do a lot of things with it. So it could be difficult to wrap your head around. Because there's a lot of potential in a method that could be challenging. So. Let's see. All right, any other, yep.
You used this keyword earlier when you were going to contain. On the method where you're entering parameters, I think you use this in getting access to other properties. The properties continue to be related to two parameters.
Yep.
How does this, what is this with the parameters when you call method?
Well, this is always going to refer to the object that owns the method. Okay. You couldn't have this keyword wouldn't work in a static class because there is no this. It has to be an instantiated object. So inside Ray, for example, inside this, I think there was a method like that. Yeah, get point. Inside this get point method, there would be something like this dot origin, this dot direction, okay? Which would be accessing the local origin and direction of this object.
That the script is attached to.
But the script is what?
That the script is attached to. So
No.
if you attach the script to a game object, will this get put the parameters of that object?
Now, the reason it would, for array, it would just be what's accessible in the array. For the reason you're seeing a lot of things related to objects is because the this that we usually use is an instance of mono behavior. And mono behavior grants us access to a lot of game object oriented things.
Oh.
because they have a this game object. Their game mono behavior is just a class, and when it gets added to a game object, the this game object is set to the parent object. So when we say this game object, it's the object that this instance of this class is attached to. This keyword is always the object, it's the instantiated object. So when I was doing, so even inside this method here, we can still access this transform and stuff like that, and that's because those are properties or fields available to us through the mono behavior. If we had a new class, so this guy is not extending, oops, is not extending mono behavior. So the this here is very limited. This is the basic, because any class is going to have object as its base, right? And that's what this is. You can see you can access the equals method, which is part of the object class. Let's just take a look at that.
But what is the object in this case?
Object is the foundational class that every object in C# extends or implements. Everything is going to be an object of some type. That new keyword is creating a new object. And the object, most of the classes are going to be some extension of objects, like this mono behavior. If we went far enough down or far enough up the tree, that root is object. And then there's going to be, you know, different types of objects that, yeah, they're all like this. My class thing that I just created is technically like this, where it's objects. Okay. When you're creating it off the root like this, you don't have to define that, but that's what it is. Every class is going to be an extension of object, and that's this method. It's when you're just referencing the root, there's not a lot of options here because it's very basic. It's these are the very basic. Any object in C#, you'll have these methods that, like the equals and well, not my method because that's right here, but toString or anything like that. So if we looked at the my controller, we see that there's the toString, which is from the object toString. Okay, there's the I think there was type, get type, which is extending from object, get type. Okay, it's this whole tree structure of objects with all of these other base classes and classes that extend them and classes that extend them, and it's this tree that spreads out and down as far as you want it to. And somewhere down one of those long branches is the mono behavior class. And so you can access everything back up the tree, everything that's public or protected. Private things would be private to that class. Yeah? So this is the keyword to access the current object, the current instantiation of the object. If you add a static method, there's no this available because there's no instance of this class. This is a static method, so there's no It says this keyword is not valid in a static property method or static field initializer. It's because
static doesn't reference an object.
static doesn't reference an object. It's a method on a class. So it's not been instantiated. So there's no this. Yeah. Any other terminology questions? You guys happy with your understanding of the dot operator? That dot right there? This dot? Okay. The dot operator is it's used for member access. So
Go back up that chain.
kind of. It's for accessing so for example the dot, this is just a reference to the current object, right? When you do a dot, that gives you access to all of the methods, properties, value, or fields associated with that object.
So, that's a question about this. So, when we, access a component of any given object, it does assume that the script that it's attached to is going to assume it's that object. Yeah. Like, sorry, I should phrase that. Like, if you attach a script to an object, by default, that script is going to, describe that object. So what's
Reference, yeah.
Yeah. What's the purpose of this then? Exactly. It seems like it's redundant.
It can be redundant a lot of the time, actually, because even though there's this, let's see, this transform, right? You can also do just transform.
Yeah.
This is not required in this situation.
Okay. So when would we have this?
So, for example, let's look at so say we had a method like this that was took a game object and a color C. If we try and reference game objects, we don't know if it's a game object or this game object. This game object would give us access to the objects, to the current instantiation's object. And just game object is giving us access to this local scope game object. Okay, so you get the situation where you can have two variables with the same name in the same scope.
That makes sense.
What was that? Yeah.
How is this not the same thing as the parameter? Or is it the same thing?
Can you explain it like in the context of something that we use when we write
Well, this could be something you use in context of VR. It's hard to contrive like a generic method that you would do this with, because you could just be careful about how you name things so that they're not the same as. So there is a method or a field called game object. It's probably on that one. Component. So there is this game object field on the component class, which makes the behavior class, which makes the monobehavior class. Okay. So things can get complex. You can have variable names that are defined way down or way up the tree, and you want to reference something that's local to yourself instead of that other one. And that's where you'd use this keyword. So referencing this game object here or just game object is going to reference the same object. But if we had it, in this guy, those are different game objects. So we could say like, we could assign game object equal to this game object. And that's actually doing something. That's reassigning this game object to the game object associated with this script.
Reassigning that variable.
Reassigning the local variable. Basically, whatever you passed in this case, would get overwritten. So it's not really a useful method or call, but it's an example. So typically, yes, the this is redundant, but just like defining the scope of things, even though this defaults to private, it's good practice to say this, because you never know when someone else is going to come along and define some local variable that's the same name as something you've been using, and now your code's messed up and it's hard to track down why.
Go back to the dot operator now.
Yep.
Sorry. More rapid.
So the dot operator is going to give you access to take any object, and the dot operator is going to give you access to its methods, properties, and fields. So for example, this dot is going to give us access to everything that's attached to the mono behavior, everything that's, yeah, it's referencing. It's like a door or a dereferencer or something that'll it's a pointer to something local instead, right? So yeah, up the tree or within the same leaf as you are. Kind of like using a directory slash. Maybe like the directory structure has a dot operator too, where you can say dot, which refers to the directory you're in, right? It's kind of like that, in that you're referring to the object that you just referenced. Okay, so anything preceding the dot is saying, with this dot operator, I want to point to the object that I just referenced here. So in this case, I'm saying this game object, and then if I do a dot operator again, that's referencing every method, field, and property that it's attached to this game object. And you can just keep going down the line until you run out, right? So it's especially easy to get very deep with this because they all have these kind of helper methods or helper properties and fields that extend the game object. So this is kind of a roundabout way of just saying this dot camera, or this dot, or you'd say this game object camera, right? This might be, yeah. So this is one of those examples of depreciated. They're trying to get rid of this this dot camera, which is basically the same as dot get component camera.
Which we ran into the other day with the set parent thing.
Yeah, kind of like that. They, with the transform parent equals versus dot set parent.
Right.
These ones, the game object camera, there's collider. These are all being depreciated because they don't want to. They were just static references, like static properties that would run that get component. It was just a shortcut way of referencing components attached to an object. They're depreciating it because there's just so many components now that they can't add this support for new ones, and they don't want to continue to support these for future ones. And it's a bit more clear if you just say get component with a specific component you're interested in. Right. So the dot operator is giving you access to everything associated with the class that precedes it, or the object that precedes it. Yeah, so like item selector, if we had a not IS. If we had this item selector class, we said item selector dot, oops, with the lowercase, we can see that with this dot operator, we can access ourselves right here. Oh, there's other things to access. Make new buttons is also a method that's on this guy right here. So this is just giving us access to all of the methods that are on this exact same script, right? So it's you could create an infinite loop by doing this, which is it calls make color pair, which then calls make color pair, which calls make color pair, and just infinitely recurses on itself until, well, let's watch. It's just it's either gonna lock up or it's gonna have a stack overflow. I think it's a stack overflow in this case. Well, we have to call it once to start with, so let's do that here. Item selector. We need to add a start method. Yeah, looks like frozen for now. It might come back with a stack overflow, but stack overflow is because when you're at a object and you call a method, it pushes that other object up onto a stack, so that when it comes back from this method, it can pull it off the stack and get back to where it was. And so if you just keep calling methods inside of it, you just keep adding things onto the stack, and eventually you get what's called a stack overflow, which is where that stack of object references or history overflows because it can only hold so many objects. So now we're frozen, probably not coming back.
That's the name of the website.
That's right. So it looks like it's still trying. It's processing. It's going to go forever, but
Oh yeah, that number just keeps climbing.
yeah, it'll just keep eating up memory. And but so that's a dot operator. Is you access the methods, fields, and properties of the previous object, and you can even use it to do this, which creates a. There is actually a use case for calling a method calling itself. It's called a recursive method, and those do work great for a lot of situations as long as you have a base case. In that, the base case is something that says, continue calling myself until you reach some endpoint. So, for example, you could have there's what's called spatial partitioning algorithms, which take a large space, break it up into 4, break up each of those smaller sections into 4, break up each of those smaller sections into 4. So you can then access objects that are in those smaller and smaller spaces. Basically a way of getting the nearest object to some other object without having to search through all of the objects to see where they all are. Is you can just step down into these smaller and smaller boxes pretty quickly, and then just search the objects that are in that little tiny box. And a recursive method there would say, step into box A, and then it would set box A to the smaller box. Step into box A, step in box A, until there are no more boxes to step into. And then it would come back up. recursive methods call themselves, so it is a valid use case to call yourself, but you need to have something that stops it. Otherwise, you get that overflow.
Can we go back to get component for a second?
Yeah. What about get component?
So just in terms of the syntax, is you had get component and then in the brackets collider and then in parentheses.
Nothing.
No?
Like that?
Right, yes. So you're getting a collider.
Yep. That's it's using the this. So even if we remove this, we know that this game object is the game object that this script references. It's this game object. Okay. And we're saying go to that game object. Let's bring back up Unity. Go to that game object and look for a component attached to that game object of type collider.
You need to assign it to something there.
Yeah, this is not being assigned to anything. This is returning a collider, but we're not assigning it. So we'd say something like, whoops, that's also named C, so we can't do that. You can only be so lazy.
So then what would go in those parentheses?
These parentheses?
Yeah.
Nothing.
Then why are they there?
These are the optional, because this is a method call, right?
But it doesn't take any argument.
Yeah, it doesn't take any arguments. It's the same as saying this to string. Too many people talking. It's the empty arguments. Okay, just like when we call make new buttons, we can actually. So another quick little tip for you: right-click on a method and say find all references, and that'll list all of the places where that method is being used. So now we can click there and see that we're using that method here in this start coroutine. Okay.
But if you wanted to put something in those parentheses, could you? Or just no?
You'd have to change the method. You couldn't. So this is back
Going
to.
back to the collider thing.
Well, this is back to methods. This is the get component is a. So imagine it without this here. It's just a method that has no arguments. Okay. This version of it would actually take a. So instead of using the pointy brackets like that and saying collider like that, maybe this will make more sense if we do it this way. Say type of collider. What does it want? It wants a type. Cannot convert type component to collider. So this just needs to be a. Well, we won't debug it right now, but this is basically what it's doing is saying, get a component that is of the type collider.
So then, above.
And that's
the
what's
game
inside.
Game object color C. Is that the argument? Like, do our.
This is the argument for this method right here.
Okay. So the things that go inside parentheses are arguments.
That's right. So this is the return type, the method name, and the arguments. And you can have 0 arguments if you want. Like toString doesn't take any arguments because all it does is takes the object and returns a string. You don't need to pass in an object for that because it already knows it's just going to return information about itself. So you don't need to pass anything in. And there's other methods of toString that allow, maybe there's other methods that allow you to pass in some formatting information. So there's versions of toString that take arguments, but the basic toString does not take any arguments. Okay? So this is the generic type. We're just specifying. It's just like that type of collider. I want you to go get a component of type collider. And this is just a way that C# deals with stuff to, it's called a generic. It allows you to specify the return type. Okay. So if we look at this, it's going to be a T. You're saying, I want you to, this is the type I'm going to tell you about, and that's also the type that you're going to return. So you can create methods that don't have a defined return type. They're just a T. This can be any letter, or it's just a variable for the return type, or the type you're passing in.
So if you had multiple colliders on an object, could you specify which collider in the?
You couldn't specify the specific collider, but you could use the get components, which will return a array of colliders, and then you could go through those colliders and pick the one you want.
My brain is still trying to put something into those parentheses. So.
All that's doing is saying this is a method, because if you just had this is probably confusing things a little bit.
Oh, because if you didn't have the parentheses.
You didn't have that, then is that a field? Is that a property? What is that?
Thank you.
It's a method.
Yes. Okay. Thank you.
It's a method that takes no arguments.
Okay.
Right? Yep.
This isn't really what we were talking about, but the microcontroller script, there's a lot going on in that script.
Yep.
And I'm kind of wondering, like, how important is the order of where things occurred in here? Like, we've got the teleporting ability, we've got the ability to pass the ray, and return information off that object. Like,
Well, so we'll start at the high level. We'll minimize these. This is all the stuff that's in the class itself, right? At the root, if you will, of the class. Okay, this is all that stuff. Minimize. I minimize these just so that the scope, everything inside of them is gone, because right now it's not important. We're just looking at how these things are organized. Okay.
and with all these things basically at the top.
At the top level, it's going to be variables and methods. There's two types of variables. There's fields and there's properties. This is a field right here, which is just a scope with a type and a name. And then this is a property that has a type, a name, and then in this case it's there's a getter and there's also a setter.
And that's what makes that a property and not a field.
That's right. And so properties are very much like fields, except that you can do extra stuff when you say, we use it down here. Let's see, find all references. So we use it down here. So when we access this reference, instead of just retrieving the information that's stored in that variable, we can go out and we can call a method and decide what to do based on the result of that method. So it's basically a way to make fields, but they're more dynamic. They're kind of on the fly fields in that we can return different information based on the current state of things, or we can call an event saying that someone has changed my value, or someone has accessed my value, or whatever it may be. Okay. So the top level has variables and methods. The order of these is not important. We could have our variables defined throughout here, intermixed between the methods. The order of the methods doesn't matter. Those can be anywhere.
It called from the top down.
The code executes from the top down, but the order of where things are placed here in the class, at the class level, is not important. It's important for structure and readability, but other than that, not important. Yep. Doesn't matter on the using statements either. Yes, this is an attribute up here. It's a modifier for the class. So in this case, so when Unity is going through and it's getting, Unity uses something called reflection, which is a term or a strategy for getting information about yourself. The code gets information about itself, okay? And a attribute adds metadata, essentially, to that information about this class. So when Unity is going through and processing all of the scripts attached to objects, it looks at that metadata information as well. And in this case, it's saying this class has meta information that says a component is an additional component is required if this class is going to be used. In this case, it's saying that component is type of SteamVR track controller. And this is not technically required. We added it in there just because we reference a tracked controller, in that we assume or we rely on a tracked controller script being on the same object as this script. So we put this in here just to ensure that anyone using this is also going to add, this script will also automatically be added.
Okay, so the reflection, the using, so we got what's between that and the using statement in terms of sort of pulling things in.
Using is shortcuts, so that instead of saying, otherwise everywhere you'd have to type Unity engine dot transform, Unity engine dot game object. Okay, this is it's removing that requirement to have all those references in there. It's basically a list of shortcuts for accessing that information. Otherwise, you'd have to put the full name of every object that or every class that you're using.
So it's referring back rather than pulling it.
Right. It's a shortcut for references, essentially.
Using SteamVR track controller.
Well, that's the name of a class itself, and these are what's called a namespace. So you can have, there's this whole hierarchy structure of namespaces where you can have Unity. Let's take a look at one. The event systems. We're using that here. No, in the update. This event system. So this is in the namespace of Unity Engine event systems. If you're using the using namespace, then you don't have to type Unity Engine.EventSystems.current. You can just type EventSystem.current. Okay, because we're using Unity Engine event systems here. Okay, so it's a shortcut for typing out names. Otherwise, you have to use the fully qualified path, right? Okay, so back to the order of classes and things, is that the order is not important here at the class level. Once you get into the scope of methods, this order is absolutely important.
If methods are part of the class level and also outside of that, I guess I'm kind of confused. I thought methods were where everything is happening.
Methods are where everything is happening, but the order of where you define the methods is not important, but the order of the insides of the methods is important. I mean, if we tried to set this marker active to false before we went out and found the marker, we can't do that. Yeah. Okay. Same thing here with this. We have to go get we have to set this device before we use it down here.
But don't you set the device at the beginning? Steam VR track controller device.
This is just creating a placeholder. This is just creating a location in memory to hold a reference to this guy. This is where I'm actually setting it, is with the equals. Okay.
It's kind of interesting to me that within those two braces, your what's happening here, but like just a couple of lines down is where it's being called, or can you go over that again?
Yeah, I called and passed and
Like that happened really quickly. I kind of thought that'd be in another area.
You mean, so we're assigning this this get component here, the device. So this is the track controller is we're saying if you add this script to an object, you also need to add this script, this track controller. Okay, so now in our code we can assume, okay, this is definitely gonna have a tracked controller because we said you had to add it if you're gonna use us. So that's why we don't have to be like if device equals null, then exit or whatever it is, right? We'd have to do some more error checking if we didn't have this guy. But this allows us to make the assumption that that script is attached. So we can just say get component, okay? And then these can technically go just right here and separate those out. So we get that component, and then that that script has these events attached to it. The events are bits of code that say when event X is triggered, I want you to call this method too. So we're passing in our methods that say when the trigger is clicked, I want you to call this trigger method that I'm giving you as well. Okay? So that's both of these, trigger and pad. And if we hit F12 on those, we can see that's these methods here. And again, it doesn't matter if these are here or there or wherever, because we have a pointer to them right here. So it doesn't matter where in the class they are, we have a pointer to where they're going to be. They don't need to be at a specific location. Okay? So we're adding those events. When this thing gets called, I want you to also call this. And so when the trigger is pressed, then we activate this code. Okay? Does that make sense? Is that what you wanted me to cover? Okay. So the inside, the actual statements inside the code are very important. The order is very important. How each of the groups of those statements or the methods are organized is not very important.
so since you're on click event args,
Uh-huh.
but yeah, so that the quick event args is the arguments that happen during a quick event.
So, okay, so let's take a look at this. Well, so the 201 class, the kind of sketchy curriculum that I've been creating for it, is going to cover events and stuff like that. But we can look at it real quick here. It's basically you define a delegate, which is a method signature, which is this guy, right? This method signature. Okay. So just assume that this is all a method signature. That's what it is. Okay. So we can define a delegate. Let's define a delegate real quick. Another one of those keywords. That is of this type. Oops. We need to call it something. I'm doing something wrong. I forget the order of things here. All right. Oh, there's where we want the name. Okay, so this is a delegate. This is basically just saying it's a way to define a specific method signature, so that when we're looking for a method to call, we can make sure that it matches this signature. It returns void, takes an object, and a clicked event args. Okay, and this trigger clicked event is saying I will call something if you give it to me, but it has to match this delegate. It has to match this delegate where it returns void, has an object sender, and a clicked event args.
What is the clicked event args?
Clicked event args is just an object that contains information about the event arguments. Okay, so it's something that when the event fires, it's going to call this method and it's going to pass in these two packages of information, right? So it's saying this is the sender that triggered the event, and this is the information about the event. And so then we can access that information here, even though we're not. We could say that trigger event pressed plus E dot, we can get information about, this is the trigger, so we can get information about if the pad was being touched, any other flags. We can get the controller index that caused the event, all kinds of stuff like that. So that clicked event args is just a way to pass around information. And so trigger event, or actually this is in the Steam code, so I think we can look at this. So this clicked event handler is that delegate right here. Delegate, clicked event handler, it needs to take an object, and clicked event args. Okay? And this is saying this is an event that needs to have a method like this. If you want to listen for this event, your method needs to look like this delegate, which is this. Okay? And saying that we have multiple different events here. There's the gripped, ungripped, trigger clicked, unclicked. Okay, all of these events for the controller. Okay? We can listen to any of those events that we want, as long as the method we're listening with, this guy, as long as the method we're listening with returns void, takes an object, and a clicked event args. And that's why both our trigger and pad methods have those same signatures. Okay, they both return void, they have object and clicked event args, which is the same as this guy here. Void, object, click event args. Yeah? That's how events work, is they define a delegate that says your method signature has to match this if you want to get information from me. And that's because, let's take a look at when those events are triggered. And all references. So this has, the track controller has a method called onTriggerClicked where it passes in some event args. And if that event is not null, then it's going to activate that event, which is what it's doing right here. And it's saying it's going to pass in itself as the thing that's the sender of that event. And it's going to pass along those event arguments. We can take another look at what would be calling those things. And you see, so the track controller has an update method. There's some configuration stuff here. It's checking to see, this is why it's nice to have the abstracted stuff, because we don't have to know about the controller state, button pressed, and there's some bit shifting going on here, and more complex stuff than we care about when we just want to know if the trigger's been clicked. So this is determining, this is saying the trigger has been pressed, the trigger was not pressed before, so this is a new event. And if that's true, then we're going to create this new clicked event args, we're going to set all the information about it, and then we're going to call that on trigger clicked event. So it's creating that event information and then passing it along, and that's what we are going to end up getting in our my controller is this clicked event args. And that's why every method that wants to listen for these events needs to accept an object and a clicked event args, because that's the information that's going to be passed along, so it needs to be ready to accept those things. Okay. Oh, it's 11:20. Let's take a break, and then we'll get back to, if you guys have more questions about stuff, we can look at that. Otherwise, we can kind of go into some next steps, and then I have some best practices to go over as well. Okay. So 10 or 15 minutes or something.